The answer to the question is that the unique Nash equilibrium of this game is middle center. Row plays middle and column plays center. And the brief explanation is that given that column plays center, it's optimal for row to play middle, and vice versa. If row plays middle, it's optimal for column to play center. And again, the equilibrium pair of strategies is denoted as middle center, and you should not answer that the equilibrium is 4-4, although those are the payoffs associated with the equilibrium pair of strategies middle center. And now we continue with repeated games, and we distinguish between repeated games that are finitely repeated, so for a limited number of periods, and infinitely repeated games that continue forever. And let's start with the finitely repeated games, and we return to Disney and Warner Brothers, who not only release movies this period or advertise for movies, but they also will advertise for future movies. So when you repeat this one-shot game, there's a time dimension into the play, and we rely on a concept we call backward induction to solve these games. So, for example, suppose that Warner Brothers and Disney repeat this game for 2 periods. Then we have period 1 and period 2. And with backward induction, we start with evaluating what is optimal for each player to do in the final period, that is period 2. And then given what they do in period 2, we go back to period 1 and consider what is optimal for them to do there. And a pair or a strategy in this case is information on what the firm will do in both period 1 and period 2. So this is a prisoner's dilemma setting because both Warner Brothers and Disney are better off if they both don't advertise when they both than compared to when they both do advertise, because not advertising will give each of them a payoff of 225, and advertising gives each a payoff of 150 only. But we observe that the Nash equilibrium of the one-shot game is for both companies to advertise, because advertising is the optimal response given that the other firm advertises. But it doesn't maximize the joint profits. So the question is, if the game is repeated for 2 periods, is the alternative strategy of not advertising sustainable as an equilibrium outcome? Using backward induction, we start in period 2 to see whether, given that the other firm doesn't advertise, it's optimal for Warner Brothers, say, to not advertise as well. And given that period 2 is the final period, the situation in which Disney and Warner Brothers find themselves is just similar to the situation of the one-shot game. Because in period 2, the final period, the game has become a one-shot game. And given that there's no future interaction anymore, if Disney decides not to advertise, the optimal response by Warner Brothers is not to not advertise as well, but to advertise. So in period 2, there's no way that Disney and Warner Brothers will stick to the decision not to advertise, because each of the firms will find it better to advertise given that the other firm does not. So if we have a finitely repeated game, the two companies cannot avoid the prisoner's dilemma, because in the final period it will unravel, and then when you go back to period 1, Disney and Warner Brothers know that in period 2 neither of them will not advertise, they both will advertise. So also in period 1 they have no reason to stick to the decision to not advertise. So without any commitment device, they both will have an incentive to cheat prior to the final period. And both firms will advertise in period 1 as well. So the prisoner's dilemma cannot be avoided in a finitely repeated game. What if the game is repeated infinitely? So we have no final period because the game will continue forever. So each period, Disney and Warner Brothers will release a new movie and will have to decide whether to advertise the movie or not. Cooperation can be sustained in some circumstances when the game is infinitely repeated, but they are somewhat more difficult to analyze. So we cannot use backward induction because we cannot start in the final period because there is no finite period in the infinitely repeated game. So instead what we will do is to consider a specific strategy and to decide whether that strategy represents a Nash equilibrium. And that may sound rather abstract, but we try to be very specific here. So we assume that the two companies plan to continue to release Lego and Frozen movies indefinitely. So you have Lego 1, Lego 2, Lego 123. And let's consider the possible strategy for each firm. So the possible strategy for Warner Brothers is, okay, Warner Brothers says, my strategy is not to advertise in the first period, and I will continue not to advertise as long as Disney doesn't advertise either. And here you can see that the strategy is really a code book because it describes every eventuality what a player will do. So here it says in period 1, I don't know, this is the first period, so I have no information on what Disney did in the past. In period 1, I definitely will not advertise. In all other periods, I will continue not to advertise as long as I have not observed Disney advertising. But may it happen that Disney advertises, then I will from then on start advertising and continue to advertise ever after. That is the strategy of Warner Brothers. So, and this exactly tells you what Warner Brothers will do in every situation. And now suppose that Disney has the same strategy. Disney will not advertise in period 1, but and it will continue not to advertise as long as it doesn't observe Warner Brothers advertising. But if it observes Warner Brothers advertising once, then it will advertise ever after. Question is, given the strategy of Warner Brothers, is Disney's strategy a Nash equilibrium strategy? And given Disney's strategy, is Warner Brothers' strategy a Nash equilibrium strategy? And to answer that question, we need to analyze whether any of the firms has an incentive to deviate from the given strategy, given that the other firm sticks to the strategy given. So whether it will have an incentive to defect. So we have our advertising game, and the matrix is the one-shot payoffs, but this is not only played in period 1, but it is played an infinite number of times. In every period, the payoff is the same. So if both firms cooperate, the lower box, right box can be sustained, and periodic payoffs will be 75 million greater for each firm. So if both don't advertise in period 1, then each will get a payoff of 225. And if that pair of action is sustained in all future periods, they can guarantee themselves a payoff of 225 in all periods of the game. So the benefits of cooperating and not advertising is an infinite stream of 75 million per period, because due to cooperation, they increase their profits from 150 to 225. And because we now consider an optimization problem across periods, we need to discount future periods, because $1 today is worth more than $1 in the future. So that are the benefits of cooperation. You can also ask, what are the costs of cooperation? Well, the cost of cooperation is that the firms will never get this payoff of 450 as long as they both don't advertise. So what you lose is, if you would advertise in a period where the opponent sticks to the strategy of not advertising, then you could earn 450 instead of 225. So the cost of cooperation is a single period payoff of 225. Now suppose that we are Warner Brothers. How should Warner Brothers evaluate the cost and benefits of cooperation when some of the payments occur in future periods? So we will discount future payoffs because there's an interest rate and there's impatience. So $1 in the future is generally observed to be less valuable than $1 a day. So we discount the future by a factor D, where D is a value between 0 and 1. So a firm considers $1 in the next period having a value of D in present value dollars. And the higher D, the greater the consideration for future payments, the more the firm cares about its future payments. And if D is 0, extreme case, the firm doesn't care at all for future periods. It discounts them completely. It only cares about the payoffs today. Okay, so we have these two strategies of Warner Brothers and Disney. And now we look at Warner Brothers. So suppose that Warner Brothers sticks to the strategy given Disney's strategy, and what are the payoffs to Warner Brothers if it deviates from that strategy by advertising in the current period. So if Warner Brothers defects, then the payoffs will be 450 today, because today it will advertise and Disney will not advertise. So it will earn 450 in terms of profits. But now, given that Warner Brothers defects by advertising today, Disney will observe that. Disney will stick to its strategy, and its strategy prescribes that if it observes Warner Brothers advertising, it will advertise in all future periods. And Warner Brothers is aware of this strategy by Disney, so it knows that if it advertises today, Disney will advertise from next period onwards till all future periods. And given that Disney advertises, the best thing that Warner Brothers can do is to advertise as well in all future periods, which will give it a payoff of 150 in each future period. And all future periods are discounted with a factor D. So the period, one period ahead, the 150 is multiplied with D. The 150 2 periods ahead is multiplied with D squared, and so on. So this is the present value payoff from defecting to Warner Brothers, given that Disney sticks to its strategy. What if instead Warner Brothers cooperates and will stick to its strategy as well? Well, in that case, it will not advertise in the current period. And Disney, based on Disney's strategy, observes that Warner Brothers doesn't advertise in the current period, so it also will not advertise in the next period. So if Warner Brothers sticks to its strategy of not advertising and not advertising as long as it doesn't observe Disney to not advertise, then Disney will never observe Warner Brothers advertising, so it will not advertise either, and they will remain in the no advertise payoff. So in that case, Warner Brothers will earn 225 today, 225 tomorrow, to 25 in the period after that, and so on until infinity. So when is it attractive for Warner Brothers to defect, to go for advertising today and reap the 450 instead of the 225? Well, it's attractive to Warner Brothers if this one period increase in payoff outweighs the decrease in future benefits of cooperation. So Warner Brothers will decide to defect if this sum is larger than this sum over here. So Warner Brothers will stick to the agreement when the stream of 225s exceeds the stream of 450 this period and 150 in all future periods. So we can simplify this entire expression. So if you rewrite it a little bit, you arrive at 75 times d plus d squared plus d cube plus and etc. And that should exceed 225. And now we can use the mathematical identity for an infinite series for values between 0 and 1 and substitute this into the condition for the Nash equilibrium that is given here. So, and this identity is that if you have a d between 0 and 1 and you have d plus d squared plus d to the power 3, then you can rewrite it as d over 1 minus d. So, and if we do that here, so we replace the sum within parentheses here by the expression d over 1 minus d, then we get that in order for Warner Brothers to stick to cooperating and not advertising, d over 1 minus d should exceed 3. And we obtain the 3 because we divide the 225 by 75. And that gives us a condition on the discount factor. So as long as the discount factor is larger than 0.75, Warner Brothers will stick to the cooperative strategy. So and you can get the intuition for that. So as long as Warner Brothers finds the futures and the payoffs in future periods sufficiently important, so this is what d larger than 0.75 means. So as long as it values the 225s sufficiently, it will not be attractive for Warner Brothers to go for the one period defection and earn 450 today. And take the other extreme. Now suppose that in practice the discount factor to Warner Brothers would be equal to 0. So d is equal to 0. Then all these terms would disappear. Warner Brothers doesn't care at all about the payoffs in future periods. So in that case, it's very clear that it should defect today and advertise, because then it would get 450 today instead of 225. So, and the same holds for Disney, because this is a situation with very symmetric payoffs. So as long as both Disney and Warner Brothers view a dollar earned in the next period to be worth at least 75 dollar cents today, the cooperative Nash equilibrium can be sustained. So to conclude, in the one-shot game, if the game is not repeated, we have these prisoner's dilemma settings where both players have a dominant strategy of not cooperating, of advertising, and that will be the Nash equilibrium outcome. The same holds if the game is repeated, but only a finite number of times, because in the final period of the game, it's akin to the one-shot situation. The players will advertise, and then by backward induction, also in the previous periods, players will find it optimal to advertise. If the game is infinitely repeated, then cooperation can be sustained, because if the players value the payoffs in future periods sufficiently, then they will not have an incentive to defect today. So underlying has been the assertion that both players will apply a grim trigger strategy. So that is a very harsh strategy that prescribes that, okay, if I observe my opponent ever to deviate from the strategy to not advertise, and I observe the firm to advertise once, then I will also advertise forever after. And I will never return to not advertising. So that's a quite forceful strategy. And cooperative play will end as soon as one of the players defects. An alternative strategy to the Grimm trigger strategy is known as the tit for tat strategy. And that works as follows. In the tit for tat strategy, you mimic the behavior of the player, the opponent's play in the previous period, which means that if your opponent cheated, defected in the former period, in the first period, then you will retaliate and you will also defect in the second period. So you will, if you observe Disney advertising in period 1, then you will advertise in period 2. But in the tit for tat strategy, you will not say, I will advertise forever after, because if you observe that the opponent doesn't advertise in period 2, then you will return as well to the action of not advertising in period 3. So in tit for tat, you do as your opponent did in the previous round. So players start coordinating, but if one of the players defects, then you will retaliate by not cooperating in the next period. But if you observe that your opponent starts cooperating again, then you forgive the player and you also start to cooperate again. So in tit for tat is nice because it starts with cooperation. It is forgiving because past defections are forgiven once the player shows cooperative behavior again. And there's also retaliation because if you defect, then your opponent will retaliate by also defecting in the next period. And that brings us to the quiz. And I must say that what we discussed in section 12.3 is not that easy, and it's good to go through a number of examples to see how repeated games, finitely repeated game and infinitely repeated games, how they work. So in the quiz we have two firms, Honda and Suzuki, and they are considering offering a 10-year full coverage warranty for new motorcycles, and the warranty offer is expensive to the firms. But if one firm offers it, it will be difficult for the other not to. And assume that the payoffs are as follows. So if Suzuki offers a warranty, it's optimal for Honda to offer a warranty as well. And if a Suzuki doesn't offer the warranty, it is optimal for Honda to offer the warranty. So in the questions asked are, if the game is played once, what is the outcome? Suppose that it's finitely repeated, in this situation 3 times. What will the outcome be different from the answer to A? And now suppose that the game is infinitely repeated and both firms have formed an agreement not to offer warranties, but they each plan to use a Grimm trigger strategy if the other defects. In that case, if both use the Grimm trigger strategy and the game is infinitely repeated, at what value of the discount factor D is Honda indifferent between sticking to the agreement and defecting on it?